Hello everyone, I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be teaching three-phase semi-converter with R load. And here, semi-converter comprises of half of the devices will be thyristors and other half will be diodes. Here, T1, T3, T5 are thyristors which are controllable devices, whereas D4, D6 and D2 are uncontrollable devices. So that is the reason we call it as semi-converter. And here let me draw the phase voltages. Take scale as 1 centimeters apart and each centimeter is equal to 60 degrees. And here R phase starts from 0, R phase is the reference, and then Y phase lags behind R phase by 120 degrees, and B phase lags behind Y phase by 120 degrees. Each are 120 degrees apart. If you see here, even in phasor diagram, R phase is the reference phase and Y phase lags behind R phase by 120 degrees and B phase lags behind Y phase by 120 degrees and R phase by 240 degrees. This is the phasor diagram and these are the phase voltages. Phase voltages R, Y, B. And here these are the line voltages and I'll teach you how to draw the line voltages. Here line voltage RY leads R phase by 30 degrees. That means, see, let us mark the scale like this. This is 30. If you see, RY phase is leading R phase by 30 degrees. So let me draw the RY phase here. These are the line voltages, RY line voltage. And RB lags behind RY phase by 60 degrees. And then another line voltage. Another line voltage, and let us connect this to back end. So these are the various line voltages. And if you see here, RY phase is leading R phase by 30 degrees. And this is RY phase, RB phase, and then YB, YR, BR, BY, and the cycle repeats. Alright, so here line voltages, each line voltage is 60 degrees apart. Each phase is 120 degrees apart. Alright, so now how to draw the output voltage. See here, this is nothing but zero crossing. This is zero crossing. And from this instant, if we can provide the triggering pulse, in that case, thyristor will be ready to conduct. Otherwise, it will not conduct before that. So here, right from zero crossing, thyristor is coming into the forward blocking state, and at alpha is equal to 30 degrees, here I am providing the triggering pulse for this particular RY phase. So here RY phase, in the sense, this is R phase and this is Y phase. And if you see, thyristor 1 anode is more positive with respect to cathode, and here negative. D6 is more negative with respect to anode. So that is the reason T1 and D6 will be conducting right from this instant called Ry, that is pi, say this zero crossing is pi by 6, where alpha is equal to 30 degrees. That means at this instant called pi by 6 plus alpha, our device starts conducting. Okay, so here this is Ry. Here we have provided the triggering pulse, and there thyristor 1 as well as D6 started conducting because of Ry phase which is appearing across the load. See here, Ry, when the moment when we provided the triggering pulse, here thyristor 1 is short circuited and it is conducting a current through the load, again through D6 and back to supply because we are feeding Ry. Ry is appeared here after zero crossing, and because of which your output waveform will be just following the line voltage, that is Ry till Ry, and the moment it reaches Ry, again zero crossing appeared, and here Rb phase is being appeared. Okay, Rb is more prominent when compared to that of Ry. So that is the reason when Rb phase is active, see, let us rub this, and now this is Rb, and because of which cathode of D2 is more negative with respect to anode. So that is the reason because of Rb phase, here thyristor 1 as well as diode D2 are conducting. Diode D2 is now more forward biased when compared to that of D6. So that is the reason D2 came into the picture. And here Rb is conducting. And how long this Rb conducts? See, here Rb is conducting. Actually, this is zero crossing. But the thing is, here Y phase, the next phase has been appeared. A Y phase in the sense, T3 need to be forward biased. So far, T1 is conducting and later T3 will be conducting because of the Y phase. But we haven't provided any triggering pulse for the thyristor 3. So that is the reason this Rb phase is continuing conduction until the instant where we provide triggering pulse for the thyristor 3. So that is the reason here Rb is conducting, and now Y phase has been appeared. There is a zero crossing, and here at this instant Y phase has been appeared. Okay, alright. See here how long this particular thyristor 1 is conducting. See, if you see, because of Rb, thyristor 1 as well as diode 2 is conducting. See here, Rb phase, because of Rb phase, T1 as well as D2 is conducting current during Rb phase. So thyristor 1 is conducting for about a period of, this is 30, 60, 90, 120, 120 degrees. Why is it so? It is because, see, here we have three thyristors. Three thyristors in the sense 360 degrees divided by 3. So each thyristor will be conducting for a period of 120 degrees. So that is the reason here T1 is conducting for a period of 120 degrees, and the moment it reaches YB appears, this is the zero crossing, and since R alpha which we have considered is 30 degrees, so that is the reason here at this particular instant our thyristor starts conducting. Since we have provided the triggering pulse at alpha is equal to 30 degrees, at this instant YB is conducting, and now the moment it reaches zero crossing, YR is more dominant when compared to that of YB. So far YB phase appeared, and because of which, let us check out, because of YB, see, Y is positive and B is negative, and because of which T3 is forward biased now, because of Y phase T3 is forward biased, and because of B phase D2 is forward biased. So that is the reason whatever the line voltage YB which we are applying will be appeared across load. So what V0 is equal to now VYB. So now here YB is conducting, and because of which T3 and D2 are active. And how long this YB conducts? Until the next zero crossing. And by this time YR came into the picture. And because of YR, so here YR in the sense, So because of YR, it is conducting till zero crossing, and beyond which YR is continuing its conduction because phase change will be taking place here, and because of which here T3 and D4 are conducting. See here, this is T3 which is conducting current through the load. Similarly, D4 is now active because of R phase. So here YB is conducting till zero crossing, and now because of YR, T3 and D4 are conducting. See here, T3 is continuing its conduction because of Y phase, and later D4 is conducting till YR phase is active. And at this instant, zero crossing is being appeared, and because of which next phase, that is BR, is being appeared. And this is a zero crossing, and zero crossing plus alpha is this particular instant at which BR comes into the picture. So now BR is active, and because of which, if you see BR in the sense B, it is making forward biasing. It is forward biasing T5, and since it is BR, so here T5 as well as D4 is conducting. T5 as well as D4 is conducting. How long? Until the next zero crossing. And now if you see, BY has been appeared. That means BY is more dominant when compared to that of BR at this particular instant. So now because of Y phase, see, because of Y phase, now see, thyristor 5 is continuing its conduction. Now D6 is more dominant when compared to that of T4. So D6 has come into the conduction state. So let me write down here, because of this B5 phase, T5 as well as D6 is conducting, and here is your output waveform, and it is continuing its conduction till here. Though RY phase has been appeared, it is because we haven't provided any triggering pulse for the thyristor 1. So what, BY is continuing its conduction till here, and the moment when we provide the triggering pulse for this particular RY phase, it starts conduction and the cycle repeats. So hope you understood. And let me give you the sequence of conduction of the devices. That is, usually it will be 6 1 1 2 2 3 3 4 5 6, and again 6 1 cycle repeats. This is how the sequence of the devices will be. So far we have seen for alpha is equal to 30 degrees V0 output voltage waveform. And now let us check out the output waveform for alpha is equal to 60 degrees. Alpha is equal to 60. See, previously this was at zero crossing, right? This is the zero crossing, and here we are providing the triggering pulse for previously. If you see the previous waveform, we have triggered for alpha is equal to 30 degrees. Now we're gonna trigger the thyristors at alpha is equal to 30 plus 30, that is alpha is equal to 60. At this instant, we are providing the triggering pulse. So what, here thyristor started conduction from this instant called pi by 6 plus alpha. That means pi by 6 is the zero crossing plus 30 plus 30, 60. At this instant, we have provided the triggering pulse. And so what, see here, RB phase is more active. If you have provided the triggering pulse at this instant called 60 degrees, now RB is active. And how long will it conduct? Till here. Till next phase has been appeared, and the moment when we provide the triggering pulse, until that instant, we will get output voltage waveform till RB phase. And because of RB phase, which two devices are conducting? Let us check out which two devices are conducting. So here this is RB. R in the sense T1 will be forward biased and it will be conducting current through the load. And now D phase, that is thyristor 1 as well as diode 2. So here T1, D2 is conducting until this instant called 5 pi by 6 plus alpha. What is 5 pi by 6? Pi by 6 is 180 by 630 into 5, 150 degrees plus 60. So far it is conducting, and now if you see at this instant, Y phase has been appeared and this is the zero crossing. This is the zero crossing. And now at alpha is equal to 60, this is the zero crossing. At alpha is equal to 60, we are providing the triggering pulse. So what? Here now YR is active. This is the zero crossing of Y phase. New phase has been appeared here. Where alpha is equal to 30 plus 30, alpha is equal to 60. This is the instant where we are providing triggering pulse for the Y phase thyristor. So that is the reason, since YR is appeared now, YR will be conducting. YR will be appeared across the load. That is output voltage is because of YR phase. So now which two devices are conducting during when YR is active? So here Y phase, because of which T3 is active, and again R phase, because of R phase D4 is active. So here T3 and D4 is conducting an output voltage. And now see how long it will conduct, as long as YR is present. So till here YR will be conducting. And at this moment, if you see, B phase has been appeared. So B phase is appeared at this instant, but our alpha is equal to 60. We will be providing the triggering pulse. We are supposed to provide the triggering pulse at this instant called alpha is equal to 60. So that is the reason from here the B phase starts conducting. How long? Right from here to here, as long as B phase is available. And at this instant, since it is becoming 0, another phase is been appeared. And if you can provide the triggering pulse, again R phase will be conducting. Hope you understood this point. So from BY, this is BY. And because of BY, which two devices are active? This is B phase, and because of which thyristor 5 is active. And again Y phase D6 is active. So what here? Now T5 as well as D6 is conducting a current through the load. So this is how we need to draw the waveforms. Let me check out for alpha is equal to 90 as well. See, if at all, if firing angle is exceeded 60 degrees, in that case, the output voltage will be discontinuous. Though it is resistive load, output voltage will be discontinuous mode. So if you see, this is alpha is pi by 6 at this instant, 0 crossing. Pi by 6 plus alpha is this is 30, this is 60, and this is 90. So at this instant, we are supposed to provide the triggering pulse. And how long it will be conducting? As long as RB is present, it will be conducting output voltage. That is from pi by 6 plus alpha to 7 pi by 6. It will be conducting. So this is your output voltage for alpha is equal to 90. Okay, we have got RB phase, and you know very well, because of RB phase, thyristor 1 as well as, so because of RB phase, here thyristor 1 as well as diode 2 will be active. Thyristor 1 as well as diode 2 will be active. So now what happens here? At this instant called 0 crossing, we have provided the triggering pulse, and now at this instant called 0 crossing, Y phase has been appeared, and we are supposed to provide the triggering pulse at alpha is equal to 90. So let us check out what is alpha is equal to 90. See, this is 30, this is 60, and this is 90. So at this instant, we will have to provide the triggering pulse. Now thyristor conducts from here. And how long it conducts? As long as this Y phase is present. So it will be conducting till here. And this is YR phase. So due to YR phase, Y in the sense thyristor 3 and YR phase, right? So D4 will be conducting. That is thyristor 3 as well as D4 is conducting as long as YR phase is being appeared. So this is how the output voltage is remain 0 from this instant to, that is the instant at 7 pi by 6 to 5 pi by 6 plus alpha, our output voltage is remain 0. So that is the reason I am saying when alpha is exceeded 60 degrees, your output voltage waveform will be discontinuous. Whereas for alpha is equal to 30 and 60, output voltage was continuous. So this is all a semi-converter. And yeah, I have explained you how to draw these line voltages. Similarly, let us draw the phasor diagram for these particular line voltages. And if you see here, RY phase is leading R phase by 30 degrees, and RB phase is lagging behind R phase by 30 degrees. That means line to line voltage phase difference is 60 degrees. That is what we have drawn. The phase difference is 60 degrees over here. And if you see, this RY phase is 30 degrees leading R phase. So that is the reason here we have drawn 30 degrees ahead of the scale. Hope you understood. So each and every line voltages will be 60 degrees apart. 60 degrees apart. Yes. Now, let us check out the output voltage expression for three-phase half-wave converter with RLO. And if you have seen V0 average, the general formula we have is 1 by T, 0 to T, V0 of omega T, d omega T, where here time period, every cycle repeats for 120 degrees. As I have already discussed, every cycle is repeating for 120 degrees. That is pi by 6 plus alpha. Pi by 6 plus alpha minus, it is conducting from, right from pi by 6 plus alpha. Is it not? And if you subtract this, we get 4 pi by 6, which is equal to 2 pi by 3. Where 2 pi by 3, 180 by 3 is 60 into 2 is 120 degrees, which we can also write it as 2 pi by 3. So this is what your time period is. So every cycle is repeating for 2 pi by 3, and it is actually conducting from pi by 6 plus alpha, and it is conducting till 5 pi by 6 plus alpha, where V0 is equal to Vm sin omega t d omega t, and this is 3 Vm by 2 pi, and integration of sine is minus cos omega t, conducting from pi by 6 plus alpha to 5 pi by 6 plus alpha. And if you simplify this, we get 3 root 3 Vm by 2 pi cos alpha. So this is nothing but your V0 average expression. In the next lecture, I'll be discussing three-phase semi-converter with RL load. Thank you.